Welcome back, Metro Ninjas, to another awesome day of virtual Mr. Coach. We're going to be talking about parallel and perpendicular lines today, but not the parallel and perpendicular lines we talked about in Unit 2, parallel and perpendicular lines as they are on a coordinate plane. So we're going to take a little bit of what we did yesterday with our slope-intercept form, point-slope form, passing through a given point. We're going to take that and apply it to our parallel and perpendicular slopes. So just a little recap. Remember that parallel lines are lines that do not intersect but are on the same plane. So the reason it's important to know if they're on the same plane, so if I draw an XY axis here, and then I were to draw a line that passes through that plane, say the slope of that line is 2. Okay? Anything, it can be anything, right? And I'm going to draw a line on a separate coordinate plane. Okay? And the slope of that line, well, let's say that is also 2. Okay? So these two lines could be parallel, but they are not because they're on two different planes. Whereas this guy exists on, let's call it coordinate plane 1, this joker exists on coordinate plane 2. So we don't know anything about coordinate plane 1 and coordinate plane 2. It could be the results of, I don't know, a rectangle or something along those lines, where one occurs here while the other occurs here. So those would be skew lines. Or it could even be a three-dimensional figure. So our parallel lines are going to exist on the same plane. Okay, now when we talk about equations for parallel lines, our equations are going to have congruent slopes. And remember, congruent means the same. So we're going to have congruent slopes, but different y-intercepts. Okay? And the reason it's got to be different, if it was the same, it would be the same line. So for a line that have the same slope and the same y-intercept, let's say we'll just make one up, y equals 2x. We'll look at this guy over here, maybe plus 1. Okay? If another line has both the same slope of 2 and the same y-intercept of 1, well, no matter how many ways we write that line, it's going to be the same line. So if it's the same line, there's not one point of intersection. There's not no points of intersection. There are infinite points of intersection. So first things first, let's take a peek at our first questions. Are these two lines parallel? So if we look back up there, we know that parallel lines must have congruent slopes but different y-intercepts. So if we take a peek at our slope is -2, and our y-intercept is 1. And on our second line, our slope is -2, and our y-intercept is -4. Okay, so first thing, do we have congruent slopes? -2, -2. Check, check. Do we have different y-intercepts? First y-intercept is 1, second y-intercept is 4. So yes, these lines are parallel. The second one, okay? Notice the first two were already in slope-intercept form for us. This guy, we've got to do a little bit of work. So remember, for slope-intercept form, it's always y equals mx plus b, where m is our slope and b is our y-intercept. So our equation on the right here is not in slope-intercept form. So before we can determine whether or not our lines are parallel, we need to make sure that we're in the same form. Okay, so we're going to add 3x to both sides. Okay, so we get y equals 3x plus 1. Okay, now we got slope-intercept form on both. Slope on the left is 3. Slope on the right is 3. So yes, we have parallel lines. Now what happens is they tried to trick us. Okay, they tried to hit us at the beginning with this -3. Okay, so when they dropped that -3 on us, they were trying to get us just to look straight at the problem without even thinking, be like, oh, that's a -3, the other side's a +3. These guys are not parallel because they don't have the same slope. But what we need to make sure we do is that both are in slope-intercept form. Okay, so that brings us to writing an equation of a line parallel to another given a singular point. So first things first, we're going to make sure that the equation should be in slope-intercept form. And we call it slope-intercept form because math people are really good with words. It gives us our slope and it gives us our intercept. That's why it's called slope-intercept form. It's that simple. Okay? So what we're going to do is we're going to write down the equation, the slope of the line they give us. Okay? I'm going to do it both ways. I'm going to do it when substituting m, solving for b, and I'm going to do it with point slope form. And then again, just like we talked about yesterday, whatever you guys are most comfortable with is what you can do. There's no one way to do this. If you're more comfortable plugging in m and then plugging in x and y and solving for b and then just redoing it at the end, that's great. If you like point slope form, that's also great. It's whatever you are most comfortable with. So we got a line that is parallel to 2x plus y equals 3 and passes through the point -2, 5. Okay, so the first thing that should jump out at us is we're not in slope-intercept form. So that's what we need to do first. We need to change our equation so it's in slope-intercept form so we can grab our slope easier. Right? So we're going to subtract 2x from both sides first, because that's going to cancel it on the right. So we get y equals -2x minus 3. So because of that, we now know the slope we're dealing with is -2. And then we have our x and we have our y. So I'm going to do it both ways on the same problem, just because I like doing math that much. So the first way, we're going to take our skeleton. So remember, it's y equals mx plus b. Okay, that's our framework. And we're going to substitute the pieces that we know. Well, we know y is 5. We know the slope has to be -2 because our lines are parallel, which means they have the same slope. We know the value of x to be -2. And then we know b to be our unknown. Once we get it set up, it's just straight linear algebra from there. Okay, so we're gonna do our simple mathematical function over there. So we got come on, Mr. Coach. Negative times negative is a positive. Okay, and then we're gonna subtract that 4 from both sides. So we get b equals 1. And if I want to plug that into my equation, I'm just going to take what I know to be my b, what I know to be my new slope, and we're going to re-put our constant variables, y and x. So we know y equals -2x plus 1. So that was using the point slope formula, or the slope-intercept formula. I'm now going to show it with our slope-intercept, our point slope, sorry. Okay, and they call it point slope because they give us a point and a slope. Okay, so we substitute the values we know. Okay, now this -2 and 5 become y1 and x1. y and x, just the plain old y and the plain old x, are going to remain constants in this equation. So y minus negative y minus 5, sorry guys, equals negative 2, because that's our slope. And then x minus negative 2. Okay. Double negative makes a positive. Okay, so in our parentheses we have x plus 2. So y minus 5 equals, when we distribute our negative 2 into both terms of our binomial, we get negative 2x minus 4. Sorry, negative 2 times a positive 2. And then we're just going to subtract or add the 5. Add 5 to both sides, so we get y equals negative 2x plus 1. Okay, they are the same. It's up to you which method you prefer. Okay, our second one, parallel line that is parallel to y equals 3x minus 5 and passes through the point negative 5, negative 2. I'm going to just go point slope on this one because it's a little easier. So y minus y1, x minus x1. We know our slope in our given line is 3. x1 is negative 5. y1 is negative 2. Okay, so we just substitute our values that we know. We just sub them right in. So we got y minus negative 2 equals our slope, which is 3, multiplied by x minus negative 5. Just like the last one, a double negative makes a positive. We distribute our 3 into both terms of our binomial. So y plus 2 equals 3x plus 15. Subtract 2 from both sides. Y equals 3x plus 13. We've got a couple more. Line that is parallel to the line y equals negative 4x plus 1 and passes through the point. This time, instead of doing point slope, I'm going to go ahead and use slope intercept. So we're going to start with the framework y equals mx plus b. Slope is negative 4. X is 2. Y is negative 1. So I can understand where there could be some hang-ups between point slope and slope intercept. In point slope form, y and x remain constants, unknown constants, whereas x1 and y1 have the value of the point that is given to us. It's all up to you, whichever one you prefer. Okay. So here we go. We know y is negative 1. Slope is negative 4. And x is 2. So we got negative 1 was negative 8 plus b. Add 8 to both sides. So we get 7 equals b. Now we take that and just plug it back in. Y and x go back to being constants, unknown constants. And our equation is negative 4x plus 7. Okay. And this last one, I'm going to go back to point slope form because again, that's my favorite one. It's the way I like to do it. Just because once you're finished with the problem, we are done. We don't have to go back and do anything extra on top of it. Okay, so we got y minus y1 equals m times x plus x1. So our slope, so remember guys, our slope is always a number and never a variable. So if it's just an x, our slope can't be x. That'll get really squirrely really fast in your equation. There is always an understood number in front of every variable that's on its own, and that understood number is a 1. So we got a slope of -1, x1 is -4, and y1 is -4 as well. They made our lives a little easier. So we substitute our unknowns. Oops. Y minus -4. Our slope was -1. X minus -4. Negative, negative makes a positive, positive. So we get y plus 4. Distribute the -1 into both terms of our binomial. Is -x minus 4. Subtract 4 from both sides. And we get y equals -x plus 8. Okay, guys, that's going to complete our lesson for today. Today we're going to talk parallel lines. Tomorrow we're going to talk perpendicular. Y'all have a wonderful rest of your day. Get your homework done. And I'll miss you guys and I love you guys. Coach O out.